Hi guys, welcome back to Mathematics for Engineering 3. This is about the integration factors. Okay, it's the sixth section. And for those who haven't watched the exact equations yet, you need to go back and watch it first, okay? Because we need to use the basic knowledge from that video in order to understand the materials in this section, okay? And for some of you who watched the exact equations but already forgot what they really are, right? We have like what integrate, differentiate, and compare, right? If you remember in the previous video about the exact equations, we have three steps, right? Integrate, differentiate, and then compare, right? So if you don't remember those steps, you just need to go back again and watch it again, and then come back here to watch the material in this section, which is the integration factor. But for those who are already familiar with the exact equations, so just please enjoy this video, okay? So let's start the integration factors. Well, if you remember, in the previous section we talked about the exact equations. What is the condition so that the equation is exact? Is that dm by dy equals dn by dy, right? So if dm by dy equals dn by dy, oops, sorry, dn by dx, we say that this equation is exact, okay? That in the previous video. But in this video, we assume that this equation is not exact. So we assume that it's not exact, which means that dm by dy is not the same as dn by dx, okay? Okay. So if it's not exact, mu, which is if mu of a function of xy, is called an integrating factor. If mu m plus mu n equals 0, this equation is exact. Okay. So just to say it again, this equation is not exact. It's not exact. But if we can find the function mu such that if you multiply mu to the equation, it becomes exact, okay? If you multiply mu to the equation, it becomes exact. We will say that the equation star is exact, okay? We will call the mu the integrating factor, okay? The mu is called an integrating factor, okay? So the question is how to find such mu, right? How to find this mu? Because if we can find this mu, we can just multiply this equation by mu, and then we get exact equation, and then we go back to the previous video, right? In the previous approach. But how to find that mu? Okay, as this is exact, so we have this condition, right? Which means that I use the formula d of uv. D of uv is u dv plus v du. Okay, make sense? If you remember, it's u dv, the derivative of u and v, right? But just delete it. I just write it here, just in case some of you don't remember. D of uv by d y in this case is u dv by dy plus v du by dy, right? Is d of uv is u dv plus v du. So here we have u v, so we have u dv plus v du. Okay, and similar for the right hand side, we have uv as well, so we have u dv plus v du. Okay, and then I move this mu to this side. Okay, and then I move this to the other side. Okay, so we can actually write mu in this form. Okay, and then right now I'm gonna talk about mu. I'm gonna look at mu in 3 different cases. The first case is when mu is a function of x. Okay, if mu is a function of x, we have a particular way to solve it. And if mu is a function of y, we have another way. And if mu is a function of x and y, okay, we're gonna split this into 3 cases. Okay, first let's look at the case when mu is the function of x. Okay, so here this guy is nothing but this. Okay, it just copy and paste. Okay, literally copy and paste. Okay, so this is a copy and paste. So the case where mu is a function of x, we have that d mu by dx is the same as d mu by dx, right? Because mu here is a function of x, which means that there's no y. So you don't need a partial derivative, right? So the partial derivative of mu by x is the same as d mu by dx, and d mu by dy is 0. Why? Because mu is a function of x, right? So there's no y. So if you take the partial derivative with respect to y, it means that x is seen as a constant, right? So the derivative of constant is 0. Okay, cool. And after that, because this guy disappear, right? Is 0, isn't it? Right? Because d mu by dy is 0. Okay, so if I just push this mu to this side and I push this n to this side, so this is what I have. Okay, and as mu is a function of x, which means that this guy is a function of x as well. Makes sense? Because guys, don't forget mu here is a function of x, right? d mu by dx, in mu there is no y, right? So d mu by dx, there's definitely no y, right? So here it's no y. So this equals this, and there's no y on this side. It means that there's no y on this side as well, which means that this guy is also a function of x. Okay, so if I let fx be this guy, okay, just try to follow me first, okay, and then I'll give you the easy way to remember how to solve the problem. But first you need to understand what's going on. Okay, so right now we have that this guy is a function of x, which means that this guy is a function of x as well. Okay, so if I let fx be this guy, okay, to make it easy to write, okay, so fx dx is the same as 1 over mu d mu. Okay, why? Because this guy is fx, right? Fx is 1 over mu d mu by dx. So fx dx is pretty much the same, like you push dx to this side. Okay. Sorry. Okay, guys. Mathematically, it doesn't work that way, as I told you many times before. Right? You can't just move the x to that side, but it works in the same way, and it's called differential form. Okay? Again, guys, this guy is fx. Fx equal 1 over mu d mu by dx. So it seems like you can move the x over there. So you have fx dx equals 1 over mu d mu. Okay? It doesn't work that way. Okay, if you want to be precise, you would need to look at the differential form. Okay, but it's the same thing. Okay, so well, after that I integrate. Okay, I integrate this equation. So if I integrate it, I need to have, you know, a constant afterwards, but let's integrate it first. So the integration of 1 over mu d mu is log of absolute mu, isn't it? Okay, and that's the integration, and then we have a constant, right? That's from this integral. Okay, so the absolute mu is this guy, right? You put you exponentiate it, right? You have, this is log with base e, so you push the e there, it's gonna be e to the power of this guy. Okay, and then guys, is e to the power of this plus this, right? It's the same as e to the power of c times e to the power of this guy. So I just split it here. Okay, and guys, c is a constant, e is also a constant, it's 2.7 something. So I call it just call it c star. Okay, I just call it c star. And guys, because here we have absolute of mu equals c star times e to the power of integrate fx dx, and as I told you guys, this mu, it can be either mu or minus mu, right? It depends. It will be mu if mu is bigger or equal that if mu is bigger or equal to 0, and it will be minus mu if mu is less than 0. Okay, but as I told you guys, it doesn't really matter. If absolute mu is mu, we use it's still a constant here. C star and c are the same thing. But if absolute mu is minus mu, c star here, c double star here is just minus of c star. But again, guys, it's just a constant, so we really don't care. Make sense? Okay, I'll take note here. If absolute mu is mu, c double star, sorry, is actually the same as c star, right? Basically, we just remove the absolute sign. But if mu is minus mu, we have that c double star is actually minus of c star. Okay. Make sense? And guys, because mu is a factor, mu is a integrating factor, that if we multiply this whole equation by mu, this equation becomes exact, right? Mu is the integrating factor, which means that if we multiply this whole equation by mu, this equation becomes exact. But guys, if mu is this, how about, if I multiply C double star? Does it matter? No, it doesn't matter because this is 0. So I can, just cancel it out. You know what I mean? So what I'm saying is that we don't really need this constant. Why? Because if mu is a constant times e to the integrate fx dx, the constant can always be cancelled out. Okay, so if you look here again, if I take mu as a C double star e to the integrate fx dx m dx plus C double star e to the integrate fx dx n dy equals 0, and then I can divide the whole equation by C double star, so this cancel out, right? Disappear. Make sense? Which means that I don't need C double star. I don't need the constant term. Make sense? That's why I, just cut this out. And mu is actually this guy. Okay? So guys, to sum it up to this point, we want to find the integrating factor, which is mu. That mu m plus mu n is 0, becomes exact. Okay? And then as it becomes exact, we have that this must be equal to this, because as it's exact, right? D of m bar by d of by dy must be equal to d of n bar by dx. Okay, and we get this equation, and then we look at the first case when mu is a function of x. If mu is a function of x, we have that this mu is this guy. Okay, so the method for when mu is a function of x, you first need to check. Okay guys, this is the method. First, you need to check if 1 over n, the m by dy minus the n by dx is a function of x, right? Because as you see here, this must be a function of x, so that mu is a function of x. Okay, first you check if this is a function of x. If yes, mu is e to the integrate fx dx. Okay, and then you multiply mu to this equation, and this equation becomes exact equation, and you use what you did in the previous video. Okay, so guys, first, when you have this equation, when you have this starting equation, first you check whether or not this is a function of x. If it is, mu is e to the integrate fx dx, which is an integrating factor. So if you multiply this mu to the equation, to this equation, you get this, and this must be exact. Okay, it will become clearer when we look at the exercises. Okay, another case when mu is a function of y. So this is nothing but again the copy and paste from here. Okay, it's the same as for the mu is the function of x case. Okay, so if mu is a function of y, we have that d mu by dy is actually the same as the mu by dy. We don't need the partial derivative anymore because mu is a function of y, which means that no x in mu, right? If there's no x in mu, partial derivative of mu with respect to y is the same as d mu by dy. And of course, as there is no x in mu, partial derivative of mu by x is 0, okay, because y is considered as a constant. Okay, so in that case, this disappeared. Oops, sorry, it's the other one. This disappeared, right? It becomes 0 because d mu by dx is 0. Okay, so guys, I move this minus m to this side and I move mu to this side. Okay, so here is the same. This remains the same here. I just move this mu here and I move this m minus m here. Okay, and as the same guy is the same as in the the x case. So as mu is a function of y, it means that this guy must be a function of y as well. Must be a function of y as well, right? Because again guys, mu is a function of y, which means that this is a function of y and this is a function of y, right? And this equals this, and here is a function of y, which means that there's no x at all. So this guy must be a function of y as well. Okay, and if that guy is a function of y, we call it gy. Okay, we call it gy. And then guys, we do substitution. We put here, this guy is gy, right? It's gy. So we have that minus gy. Okay, minus gy. Here we have this guy is gy. So we have that minus gy equals 1 over mu d mu by dy. And then again, we push dy to this side. Okay, that's why we get minus gy 1 over mu d mu. Okay, that's the differential form. Okay, it's similar to the previous section. And then we integrate. Same. So we get log absolute mu. Same thing. And here we have minus of integrate gy dy plus c. And then we exponentiate. We get this the same. And this is the same. Okay. And again, I remove this absolute. I should have got the c double star, and then I remove the c, because as I told you, even if you multiply the whole equation by c double star, it doesn't change anything. Okay, you don't need a constant. So basically, mu is going to be e to the power of minus integrate gy dy. So the method, when mu is a function of y, first you need to check if this is a function of y. Okay. Why? Because again, here it's similar here. We have that this is a function of y. Okay, so if this is a function of y, we have that mu is a function of y as well. It's the other way around. See? So if you can check that this is a function of y, you get gy. And then mu is e to the minus integrate gy dy. It's an integrating factor, right? From here. Okay, from there, from what we had in the previous slide. And next we have that if you multiply the equation, this equation by mu, you get this and it becomes exact equation. Okay, okay, makes sense. Okay, take home message. Take home message. I know, guys. There are lots of things to learn in this course. This is just the first chapter, and we already have like lots of forms, right? We have separable, we have homogeneous, we have when the coefficients are linear, right? Linear equations, and we have exact equations. We do have lots of forms, right? We do have lots of forms, but that's why I tend to do this slide for you guys, the take home message. Take home message, right? Is one slide that tell you everything, so that it's easier for you guys to memorize things. But it won't help if you don't do exercises. Okay, guys, mathematics, it will become clearer and clearer when you keep doing exercises, and you will remember the method, right? You don't need to go back and forth. If you keep doing like 10 exercises, you will be really familiar with the method, and you don't need to you don't need to memorize them anymore, right? Because you are already familiar with the method. Okay, so the take home message is that if you have this function, m dx plus n dy equals 0, and it's not exact, okay? Because if it's exact, we would go back to the previous video, right, and use the exact approach to solve it. Okay, so assume that it's not exact. First, we check if this is a function of x. If it is, we let mu be this guy. Okay, and then if not, we check if this is a function of y. If yes, this is the mu, the integrating factor, sorry. Okay, so we have two cases when this guy or mu is a function of x, and this is when this guy or mu is a function of y. Okay, we can define mu in this way. Okay, and then we multiply mu to this equation, and then this equation becomes exact equation. I should write mu star becomes a exact equation. But some of you may ask me, at the beginning I talk about 3 cases, right? When mu is a function of x, when mu is a function of y, which is this case, and I have another case when mu is a function of x and y, which means that this is not a function of x, it has both x and y, and this is not a function of y, it has both x and y. What would you do? In that case, you can't get the closed form for mu. You can't find mu. So you need to use the observation method, right? The one that we used in the previous sector, remember? In the previous section. But guys, try to avoid the observation method. Okay? That would be the last thing that you would do. Okay? You can't find any methods to solve it. And then, okay guys, just use the observation method, okay? Okay, but please be focusing on these 2 cases. But I'll have some examples at the end as well to show you when it doesn't fit both cases and what should we do. Okay, I'll tell you later, nearly at the end of the section. Okay, let's look at an example. Guys, mathematics, things become clear when we look at examples and exercises. Okay, so this one. First, we know that m, xy is xy plus y squared, right? This guy is m. Okay, and n is x plus 2y minus 1. Okay, and then guys, I find the derivative of m by y. So what I have is x, just x plus 2y, isn't it? Right? Because if we take the derivative of m by y, we look at x as a constant. X is considered as a constant. Okay? Okay. So here is y to the power of 1. You push 1 here, it becomes y to the power of 0, which is 1. Right? And this is 2y. We have, y squared. So we have 2y. And dn by dx, again, we look at y as a constant. So the n by dx is 1 and this is 0. This is 0, right? Because y is a constant. Okay? Okay. So first, look at the take-home message. First, we need to look at this guy, right? We need to look at this guy. So 1 over n dm by dy minus dn by dx. What is it? What is it? Okay, guys. First, we can see that this is not exact, right? Because if it was exact, they would be equal, right? Right? If it were exact, they would be equal. These two things, right? Because for an equation to be exact, dm by dy equals dn by dx, right? Right? Which means that this is not exact because they aren't equal. Okay? So if you look at that one, what is it? You have 1 divided by n is x plus 2y minus 1. And dm by dy is x plus 2y minus 1. And that is actually 1. Okay? 1 is a constant, right? 1 is a constant, right? If it's a constant, it means that there's no y, right? No y. Can I say that it's a function of x? The answer is yes. Because there's no y, I can say it's a function of x, right? Because first we need to check if this is a function of x. But guys, fx equal to, that's a function of x as well, right? Because it can be x to the power of 0. Okay? Any constant can be a function of x. And similarly, any constant can be a function of y as well. Okay? Okay? So it means that a constant here is actually a function of x. We can look at it as a function of x. So we let fx be 1. Okay? Guys, look at the take-home message. We look at this, and this is a function of x. So fx be this term. Okay? But this guy is 1, which means that fx is 1. Okay? And then we have our integrating factor. Mu is e to the integrate fx dx, which is what? E to the integrate 1 dx, which is e to the x, right? So we know that if we multiply e to the x, I'll call this equation star. If we multiply e to the x to the equation star, we must receive the exact equation, right? So what we have is mu xy plus y squared dx plus mu x plus 2y minus 1 dy. equals 0. Okay, okay. But guys, mu is e to the x, right? Oops, sorry. I call this double star. And we know that this double star is actually exact. Okay. In the exam, you don't need to check it. You don't need to check it. Because if you define mu in this way, it's always exact. But it's a good practice to check it. Why? Because if you do something wrong here, right, you come up with the wrong mu. And then if you didn't check, you proceed without checking. And then you do, a lot more things. And at the end, it's gonna be wrong. Okay? Okay? So if you check here, it's like a checkpoint. It's a checkpoint to see whether or not thing is going as expected. Makes sense? It's like a checking point. So you are not required to check, but I highly recommend you to check whether or not it's exact. Because if you get that it's exact, it's like it means that what you did here is correct. Okay, and you already receive half of the points. Okay, half of the points for this question. Okay. But if you didn't check and you are so confident that you get the correct mu, and it turns out that it's wrong, and then here it's gonna be wrong, and then you keep using mu further, and all is going to be wrong, and you're gonna get more or less 0. Okay, so as I told you, you are not required to check whether or not this equation is exact, but as I told you, I highly recommend you to check it. So if you have time in the exam, just check it. Okay, but if you are running out of time, you can skip it. It's okay. Okay, well, as an example, I will check it anyway. So I'll let mx bar y bar m bar xy be e to the x xy plus y squared. So which is this guy? Okay. So dy by dm, what is it? Oh, sorry, dm by dy. What is it? dm by dy. dm bar by dy is gonna be d of u. Oops. We take the derivative by y, right? So x is a constant, so I don't care. It's e to the x here, and then dxy is x, and dy squared is 2y, and that is my dm bar by dy. And again, guys, n bar xy equals x plus 2y minus 1. Okay, oops, sorry. Is e to the x x 2y minus 1. Okay, is this guy. Make sense? So the n bar by dy would be the n bar by the x. Okay, the n bar by the x would be, what is it? So in this case, this is a function of x. I need to use d by the x of uv, right? Which is u dv plus v du. Okay, so u dv must be 1, right? Because y are seen as constants. Guys, we take derivative by x. Okay, y are seen as constants. So is e to the x 1 u dv plus v, which is x plus 2y minus 1. dx is e to the x. Okay, so what I have here, I'll pull e to the x out. So I have 1 plus x plus 2y minus 1. And this 1 got cancelled out. So we can see that this guy and this guy are equal. See? So we have that dm bar by dy equals dn bar by dx, which means that the equation double star, this equation, is exact. Make sense? Does it make sense? Okay, I could have stopped here, right? Because once this equation becomes exact, you just go back to the previous video and see how to solve it. Okay, but as an example for this one, I'm gonna solve it for you to see. Okay, but in the next questions, I'm gonna let you solve it yourself. Okay, I'm just gonna show that you can find the integrating factor and then you turn it into the exact equation. Okay, so it's actually done here. In the material in this video. So what I'm going to do next is from the previous video, which is how to solve exact equations. Okay. So if you remember, we begin with when we know that the equation is exact, we have that df by dx is e to the x xy plus y squared, and df by dy is e to the x x plus 2y minus 1, right? We begin with these two okay, let me write it again. It's quite hard for some of you to read, I know. Is e to the x x plus 2y minus 1. Okay, x plus 2y minus 1. And then you have choice to first, you have two choices, right? You can begin with this or begin with this, right? And what you need to do is that first you need to integrate. Second, differentiate. And third, you compare, right? That is from the previous video. So you can either begin with this or this. It's up to you. Both works as I told you. But guys, if you begin with this, you need to integrate by x, right? Your f is going to be integrate of this guy dx plus the function of y, if you remember, right? But guys, to integrate this function is e to the x times x, right? In that case, you need to use integration by parts, right? You need integration by parts, and that is relatively harder. It's not hard, but it's relatively harder. Okay, so I would say that it is easier to begin with df by dy equals e to the x x plus 2y minus 1. Why? Because if you begin with this equation, you just need your fx your f is integrate this guy dy plus px, right? 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 But if you want to integrate this guy dy, x is considered as a constant, so you have only y here. It's easy to integrate. You see? You see? Okay, so it's easier to integrate df by dy. So guys, just to remind you, we can begin with either one of these. It is in the previous video, okay? But I want to, you know, to talk about it again, just in case some of you forgot. So if you begin with df by dy, it's easier to integrate. Okay, so I'll begin with this one. I'll just copy this. Okay, and then I get a new page here. So if I begin with this guy, what would I have? Okay, I'll copy and paste the equation as well, so that I have thing to compare. So that is the exact equation, right? So first we integrate. So we have that f is integrate e to the x plus 2y minus 1 dy plus px. Right? We have px as we take the partial integration by y. So we need to have the function of x as a constant, right? Right. So here we integrate by y, so x is considered as a constant, so I pull e to the x out, so it's integrate x plus 2y minus 1 dy plus px. So we have I think in the previous video I call it gx, so I just stick with gx, okay, not to make you guys confused. So is e to the x, and that is x y plus 2y squared divided by 2 minus y plus gx, right? And that will be e to the x xy plus y squared minus y plus gy. And then second, you need to differentiate. So we have that df by dx is, what is it? First we integrate dy, right? So we need to differentiate by dx. So what is df by dx? Is, well, here we need to use du and v, right? So it's u dv. dv is differentiate by x, so y is seen as a constant, so we have y, just y, right? Because the derivative of y squared minus y is 0, because y is seen as a constant, right? Derivative of constant is 0. And then plus v du. V is this guy, du is e to the x. Okay, so df by dx is e to the xy plus xy e to the x plus y squared e to the x minus y e to the x. So this got cancelled out. Okay, and then we compared this with this guy. Okay, oops, sorry, I forgot g prime y. sorry, g prime x. G is a function of x, okay? Sorry for my handwriting. Okay, I've got g prime x. So I have plus g prime x. Okay, so I need to compare this with the f by the x, right? I need to compare this with the f by the x, right? Or if you remember from the previous slide, the f by the x is this guy, which is actually this guy, right? Right. So I need to compare it with here. But as you can see, you have xy e to the x, you have xy e to the x, you have y squared e to the x, you have y squared e to the x. It means that g prime x is actually 0, right? Because if you compare the f by the x, which is this guy, with this, which is the f by the x, you have that this cancel out with this, which means that g prime x is actually 0, and that means gx is just a constant. Okay, so the solution is f xy equals c, right? So the f, what is f? F is from here, right? E to the x, xy plus y squared minus y plus c. Okay. Equals, can I call this c1? Okay, because you know g prime x equals 0, so gx is a constant. I call it c1, okay, not to be confused with this c. Equals c. But guys, this is a constant as well. Okay, guys, for some of you who are confused, f is this guy, right? The solution is f equals c. So this is just that, and gx is c1, okay, equals c. But guys, both c1 and c are constant, okay? So I'll just push this c1 to that side, and I group them together. So I have e to the x, xy plus y squared minus y equals c star, okay? Or you can write c if you want, because it's just a constant. Okay, it's such a long question, isn't it? Right? It's a long question. But anyway, what we have learned today is actually not the whole thing. It's just here. We can just stop here, right? When we can identify the integrating factor, and when we multiply the integrating factor to this equation, the equation star, we have the equation double star, and we prove that double star is exact, right? And that's it. After that, we need to use the knowledge from the previous video to solve it, right? So it's like we have an equation which is not exact, and if it satisfies this condition, right? If this is a function of x, we can find mu. That, you know, if we multiply mu to this equation, we get another equation which is exact. So that's how it works. Okay. So let's look at okay, before we look at another example, in the previous video we look at how to solve this equation using observation method, right? right? As I told you, for exact equation, you can do it two ways. The first way is the direct method, which is the one I just did, and it's the one I recommend you guys to do, okay? Because it's easier. It's longer, but it's easier, okay? The other approach is the observation method. Okay, so I'll show you the observation method as well. So I'll just copy and paste this guy. How to solve this equation using an observation method. Okay, I'll just write it here. Observation method. You don't need to do it, okay? I just show it so that for those who are interested in this method can have a look, okay? So to solve this equation using an observation method is quite tricky. You need to be really smart, okay? You need to practice a lot, and it's gonna be faster if you can if you can solve it using this method. Okay, first I'll just distribute this guy. So I have e to the x xy dx, okay, plus e to the x y squared dx plus e to the x x dy plus 2e to the x y dy minus e to the x dy equals 0. I don't know what to do, so I just just distribute e to the x to the into the parentheses, okay? And after that, if you look at okay, first if you look here, I'll keep it this one the same, okay? I'll keep it the same, but this one, guys, this one, if you look at it, it's actually y squared d of e to the x, right? Because, guys, don't forget, d of e to the x is e to the x dx, right? So you have e to the x dx, that becomes d of e to the x, okay? And another one, I'll keep it that way, dy plus and this is as you can see here is e to the x dy squared, right? I try to do it like slowly because dy squared is 2y, dy squared is 2y dy, right? Dy squared is 2y dy. Make sense? Okay, it's a differential form, okay? So d2y dy squared is 2y dy, and the last one I keep it the same, minus e to the x dy, okay? Guys, if you look at these two terms, we know that y squared de to the x plus e to the x dy squared, that is d of e to the x y squared, isn't it? Right? Here I just this is this term and this is that term, is u dv plus v du, that's duv. Make sense? Okay. And guys, as you have let me look at it. What else do we have? Guys, as you can see, we have this term, and this term left, right? So if we have u, if we look at this as u dv, we should have y d of e to the x, right? We should have v du. Okay, that's how I observe it, because we have u dv. Okay, so I'm just gonna look at this one, which is d of y e to the xx. Okay, because I observe this term because I see this term, and I hope that if I get u dv, and if I have v du, it will be d of vu or uv. Okay, so here is, what is it? It will be u dv. dv is e to the x plus x e to the x dx, right? Plus v, which is e to the x du, which is dy. Okay, and see this term is the same as this term. That's my observation. I see that if I take this derivative, I will get this term out. Okay, and then I'll just write it a bit better. So I have y e to the x dx plus xy e to the x dx plus e to the x dy. So again, I know that this term is actually this term. And again, guys, this term is actually that term, right? So if I have this term, I can write this as d of y e to the xx, right? But I don't have that yet. We don't have this term anywhere here. Okay, let's continue it here. I'll just continue it here. So guys, I'll go with this term first, which is d e to the x y squared, which is from these two terms. Make sense? And then I have e to the x xy dx plus e to the x dy. And then if I plus y e to the x, okay, I'll use other colors. If I plus y e to the x dx, and then I need to minus it out, and then minus e to the x dy. Okay, and in that case, I have this guy. I have this guy here. I have this guy here as well, right? This guy is this guy, and this guy is that guy. And I also plus this guy into the equation. So I already have it. Okay. So in that case, I can write this equation is equals 0 though. Forgot to write. I can write this equation as d of e to the x y squared plus d of y e to the xx. Right? These three terms combined and becomes this term. Okay? I told you, it's easier to use the direct method. Okay? This would be the last method I would use, okay? But if you want to practice your mind, it's like playing Sudoku, right? You need to keep putting numbers in there. So here as well, it's like playing Sudoku. It's just maybe it's arguably harder. Okay, you can keep practicing this on the BTS instead of Sudoku. When others are doing Sudoku, you just doing the observation method. Come up with the equations and try to find the right combination. Okay, so it's dy e to the x, and then you have these two terms left, right? So I'll write it as the minus of y. Okay, guys, this one, if you look at it, it's actually y de to the x, right? Plus e to the x dy. Right, guys, because d of e to the x is e to the x dx, right? So this is d to the x, d of e to the x. Okay, and that equals 0. So we have d e to the x y squared plus dy e to the xx minus d of e to the xy equals 0, right? Because this is u dv plus v du, so we have duv. Okay, and in that case we have that d of e to the x y squared plus e to the xx minus e to the xy equals 0, which means that the solution is e to the x y squared plus e to the xx minus e to the xy equals c. Okay, and if I pull e to the x out, that will be y squared plus x minus y equals c. Okay. Oh, guys, sorry, I forgot this y here. It's the y e to x, right? And then I just drop y. Sorry, I have y here. So I must have y here as well. So I have y here as well. Okay. Because I'm looking at it and it's not the same as in the previous page. Right? So if you look here and you compare it with the one we get in the previous page, they are exactly the same. See? They are exactly the same. So it's up to you if you want to use the observation method, but I wouldn't recommend it. Okay, but if you want to, so it's your choice. Okay, so let's look at another question. This one. So again, we need to first look at m of xy, which is what equals 4xy plus 3y squared minus x, and so the m by dy is 4x plus 6y. Okay, and guys, n xy is, what is it? x plus 2y. So dn by dx is duv, right? udv plus vdu. So it's x 2, oops, sorry, 1 plus x plus 2y 1. So it's actually 2x plus 2y. So I'll just look first. We can say that it's not an exact equation, right? Because this and this aren't equal. So it's not an exact equation. Okay. After that, I'll write the dm by dy minus dn by dx first, and it is, what is it, 4x plus 6y minus 2x minus 2y, right? Or you can write it this way, it's minus 2x plus 2y, and that is 2x plus 4y. Okay, and then I look at, what is it, what do we need to look at? It's 1 over n dm by dx or dm by dy minus dn by dx, and that is 1 over n. N is x plus 2y, right? Dm by dy minus dn by dx would be 2x plus 4y. And then if I pull 2 out, I would get 2x plus 2y divided by x plus 2y. So this got cancelled out. So this guy is 2 divided by x, which is a function of x, right? So if it's a function of x, we let fx be 2 over x. Okay, and the integrating factor is e to the integrate fx dx, right? Is 2 over x dx. So we have is e to the 2 log absolute x, and is actually e to the log of absolute x squared, which is absolute x squared, right guys? Don't forget, e to the log of something is that thing, right? The log and the e are cancelled out. Okay, and because it's absolute, squared is always positive, right? So I don't need absolute anymore, so it's x squared. Okay, that's the integrating factor. And then what I have here is that I multiply mu to the equation star. I'll call it star. Okay, so what I have is, what is it, x squared, and I have 4xy plus 3y squared minus x dx plus x squared x plus 2y dy equals 0. Okay, and I call this equation double star. And we know that this double star is exact, right? But if you want to check, and I recommend you to check, okay? If you want to check, just check it. We have that m bar xy is okay, what is it? It's 4x cubed y plus 3x squared y squared minus x cubed. Okay, and n bar xy is x to the power of 4 plus 2x cubed y. Okay, and then we know that the m bar by dy is, what is it, 4x cubed plus 6x squared y, and x cubed disappeared because it's just a constant, right? Because we take the derivative by y, and the n bar by dx is 4x cubed plus 6x squared y. So guys, you can see that these guys are equal. They are equal, which means that the equation double star is exact as we expected. Okay, so we can begin with two choices. The first choice would be to begin with the f by dx is, what is it, 4x cubed y plus 3x squared y squared minus x cubed, right? Which is this part. We can begin with this, or we can begin with the f by dy equals x to the power of 4 plus 2x cubed y. We have two choices, this one and that one. Okay, if we begin with this one, we need to integrate this by x first and then differentiate it by y and then compare, right? If we begin with this, we need to first integrate this by y and differentiate it by x. I think both of them are easy to begin with. If you want to begin with, either of them is fine. But if I were you, I would begin here, because there's only one y here, right? It's only one y here. It's much easier to integrate, right? You have just you have y here, and then you have y squared divided by 2, and this cancel out, right? It's much easier to integrate. But guys, I'm not going to do that for you for this question. Okay, I did it for you in the previous one, and that took me quite a long time. Okay, so I'm not gonna do the whole thing, but as it is exact, so I think you guys can use the direct method, right? I begin it for you here using this. So first you integrate by y, differentiate by x, and then you compare. Okay, I give the solution for you here. So the solution is x cubed 4xy plus 4y squared minus x equals c. Okay, so you guys can try it yourself and see whether or not you get this solution. Okay, or you get your solution is equivalent to the solution above. If not, you can come and ask me. Okay, you'll probably get something wrong somewhere. So just try to solve it yourself. Okay, it's like an exercise for the exact equation section. Okay, well, I'll go to the next section. Oh, sorry, the next question, which is this one. Okay, this question is the same, guys. First, we need to look at the mxy is, what is it? I just call it m, okay, to make it shorter. M is y x plus y plus 1, which is xy plus y squared plus y. Okay, so we have that the m by dy, use this color, the m by dy is x plus 2y plus 1. Okay, and similarly, we have that n is x plus 3y plus 2. So we have that is x squared plus 3xy plus 2x, right? So we have that the n by the x. Okay, guys, if you keep practicing, you're gonna get really familiar with it. You're gonna, remember how to do it. Okay, it's like playing games. 2x plus 3y plus 2. Okay, from here, right? 2x, 3y, and 2, right? Differentiated by x. So, and as you can see, guys, it isn't exact. It's not exact yet, because the n by dy is not the same as the n by the x. Okay, so it's not exact. So first, I'll compute the the m by dy minus the n by dx. And what is it? Is can I do that now? It's like x minus 2x, right? It's x. Okay, I'll just write it, just in case some of you get confused. 2y plus 1 minus 2x plus 3y plus 2. Guys, this is a common mistake. I guarantee that one of you is going to get this mistake in the exam. And it's a silly mistake, which is to forget the parentheses. Okay, it's minus, so you need a parenthesis. Okay, otherwise you would need to put this as minus and minus. Okay, so this is a 2x minus 2x, which is minus x, and 2y minus 3y, you get minus y, and minus 1. Okay, so what I have is the m by dy minus the n by the x, and then I want to check the the one that we usually check first, which is 1 over n, the m by dy minus the n by the x, and that is, what is it? 1 over n. Okay, I'll write the m by dy minus the n by the x first, and it's minus x minus y and minus 1 divided by over n, right? Over n divided by n is x, x plus 3y plus 2. Okay, this guy, this guy is n. Okay, and this guy is this. Make sense? And as you can see, you can't make it a function of x. It's not a function of x. It's not a function of x. So let's hope that 1 over m the m by dy minus the n by dx is a function of y. Okay, let's hope that it's a function of y. Okay, because right now, if you look at the take-home message, right now we know that this is not a function of x. We can't use this anymore, right? Because it's not a function of x. So we're gonna look at this, whether or not this is a function of y. Okay, so 1 over m the m by dy minus the n by dx. So it's here 1 over m the m by dy minus the n by dx, and that is, what is it? the same is minus x minus y minus 1. That is this guy, right? And then divided by m. M is y, x plus 1 plus y plus 1. And as you can see, if I pull minus out, you get x plus 1 plus y, plus 1 divided by y, x plus y plus 1. And this got cancelled out. And what I have is minus 1 divided by y. Okay? And as you see, it's actually a function of y. Okay, it's a function of y. So in that case, the integrating factor is defined as minus of gy dy. Okay? If you don't remember, go back to the take-home message. Okay? You're gonna see that the integrating factor is e to the minus integrate gy dy. And that is e to the minus integrate minus 1 over y dy. And is e to the integrate 1 over y dy, which is e to the log of absolute y, which is absolute y. Okay? But guys, as you know, absolute y can be either y or minus y, right? Depends if y is not less than 0 or y is less than 0, right? We have two cases. The absolute y can be y and minus y. But guys, this is the trick we use quite a lot. Okay, this is a trick we use quite a lot. If you multiply absolute y to the equation star. Okay, you need to choose between multiply y to star or minus y to star. Okay, because you know the absolute y, it can be either y or minus y, right? But if you want to multiply y to this star or multiply minus y to star, you have the same result. You have the same result. Why? Because if you multiply this by y, you get y here, right? If you multiply it by minus y, you get minus y here, right? But if you multiply it by minus y, okay, let's say if I multiply it by minus y, and then I multiply the whole equation by minus 1, it's gonna turn out to be y again. Make sense? Again, guys, if I multiply the whole equation by minus y, right? So I have minus y here, and minus y there, right? I multiply the whole equation by minus y, and again I multiply the whole equation by minus 1. So this becomes plus, this becomes plus, and it's the same as to multiply the whole equation by y. Okay, so even if the integrating factor is absolute y, which can be y or minus y, right? It can be either y or minus y, but it doesn't really matter, because if you multiply y to the star, you get y and y, right? But if you multiply minus y to star, you get minus y. But you know, you can multiply the whole equation by minus 1 and it would change to y again. So they are the same. Okay, so we can just use mu equals y. Okay, so I'll copy this equation to the new page. Okay, guys, if you multiply this by mu by y, guys, again, you need to understand this because you're gonna see it quite a lot when mu is an absolute function. Okay, if mu can be y or minus y, right? So I'm gonna write that for you so that you can understand it. So if mu is y, we have that is y x plus y plus 1 dx plus xy is y squared, right? You multiply it by y. Okay, so how about I write it like this: y and xy and yx x plus 3y plus 2 dy equals 0. If mu is minus y, we have minus y x plus y plus 1 dx minus yx x plus 3y plus 2 dy equals 0. And then I multiply by minus 1. So I have, what is it? y x plus y plus 1 dx plus yx x plus 3y plus 2 dy equals 0. And these two equations are exactly the same. Okay? So even if you can be, absolute y, which is y or minus y, but you don't care. Because if you use mu as y, you get this. If you use mu as minus y, you get this, which is exactly the same. Okay, so I just gonna ignore this case and I'll just let mu be just y. Okay, so this equation a turns to be the y squared x plus y plus 1 dx plus xy x plus 3y plus 2 dy equals 0. And I call this double star. And we know that this double star is an exact right? We know that it's an exact equation. Okay, but we want to show it. So we get m bar equals y squared x plus y plus 1 and n bar equals xy x plus 3y plus 2. Okay, and then we have that dm by dy is uv, right? udv plus vdu, which is y squared 1 plus x plus y plus 1, right? v du is 2y. So we have 3y squared, right? We have this is y and 2y, so it's 2y squared plus y squared, that's 3y squared plus 2xy plus 2y. Okay, the other one is dn by dx is xy and then d by dx, which is 1, the rest is 0, plus vdu, which is x plus 3y plus 2 du is y. So we have that is actually 3y squared plus 2xy plus 2y. So they are the same, okay, which means that is this equation double star is actually exact. Okay, so again you can begin with df by dx equals y squared x plus y plus 1, or you can begin with df by dy equals xy x plus 3y plus 2. Okay, but for this case either are fine, they are easy, right? You don't have exponential, you don't need to do integration by parts, right? Both are simple, but this one is probably a little bit, just a little bit easier. Why? Because integrate this by x, you have only one x here, right? So if you want to integrate, it's a little bit easier. But here you have you have lots of y, so it's probably a little bit harder, but they are actually the same. So you can begin with either one of them. Okay, integrate, differentiate, and then compare. Okay, and then you get the solution. Okay, I won't do it. Okay, so you can do it yourself. Cool. Okay. Okay guys, for this question you can do it as an exercise, okay? I'll tell you that the mu is actually absolute y, okay? And as you know, it can be y or minus y, but it's the same as in the previous question. It's that you can just use it as y, right? You don't need to care about the minus y, right? Because it's gonna be the same. To multiply the whole equation by y or minus y are the same. Okay, and the solution is 2x y squared minus y squared e to the x plus 3x squared y cubed minus 2y cubed minus 2y squared equals c. And that is the solution. Okay, just try it. Okay, if we have time, we can do that in our live class. Okay, cool. Okay, let's look at another question. This one guys. Again guys, it's a repetition, right? We keep doing the same things over and over. So here m is x squared y plus y cubed minus y. So we have that dm by dy is x squared plus 3y squared minus 1, right? Just differentiate by y. X is considered as a constant. Okay, so n is x cubed plus x y squared and plus x. Okay, so dn by dx would be 3x squared plus y squared plus 1. Okay, so we have that dm by dx, dy minus dn by dx is, what is it? It will be x squared plus 3y squared minus 1 subtracted by 3x squared plus y squared plus 1. and that is actually whoa, minus 2x squared plus 2y squared minus 2, and I pull the minus 2 out, so I get x squared minus y squared and plus 1, right? Minus 2x squared minus y squared plus 1. Okay, guys, is that good? Okay, so we can see that it is clear. Is it clear that first 1 over n dm by dx minus dn by dx, which is, you know, this one divided by n, which is divided by 3x squared plus y squared plus 1, right? Divided by this, sorry, this one divided by n, which is divided by x cubed plus xy squared plus x, which is this guy, right? It's not a function of x. It's not a function of x. It's not a function of x. And as you can see, this guy sorry, this is by dy, okay? My bad. It's not a function of y as well. Why? Because here this guy is minus 2x squared minus y squared plus 1, right? If you divide that by m, it's x squared plus, sorry, x squared y. Yeah, I'll write it again. Minus 2x squared minus y squared plus 1 divided by m. M is x squared y plus y cubed minus y. And that is definitely not a function of y. Okay? Okay? So, in this case, we can't have mu as e integrate fx dx or e integrate minus gy dy. We can't have that, right? We can't have that. Okay, so what can we do? What can we do? First, you need to look at some other approaches first, okay? Look at, you know, some other methods that we have learned, you know, the what is it, homogeneous, separable, and, you know, all other things, and the equations that we are going to be learning in the next sections as well. So look at those approaches first, okay? If you can't simplify a good approach for this problem, then we need to use the observation method, okay? So if the other don't fit sorry, if the equation doesn't fit the other approaches, then we need to go back to the observation method. Okay, we need to use the observation method. But guys, it's not a good idea to go to the observation method. Okay, always not a good idea. Okay. So let's try to observe it first. Okay. Let's look at the equation, this equation, and using y side here. Unless you are a genius. Okay. So x squared. But you don't need to be a genius in order to do the observation method. But it requires some thinking. The x minus y the x. This is not saying I just distribute the x into the parentheses. Okay. So again I do the same thing for dy. So I get x cubed dy plus xy squared dy plus x dy equals 0. Okay. And then guys, do you see this? I'll pull y squared out. I'll pull y out. So what I get is x squared plus y squared, and then we have y dx. Okay. And minus y dy. Oh, sorry, minus y dx. Plus, and I do the same for this. I pull x out, so I get x, and what is it? X squared, right this way. X squared plus y squared, x dy. And then I have plus x dy equals 0. Okay. And then I just put it together, just write it in a better way. So what I have is x squared plus y squared y dy dx plus x squared plus y squared x dy. Okay. Plus x dy minus y dx equals 0. Oops. Sorry. That equals 0. Okay. And then I'll copy this to the next page. I'll let you guys see this first. Okay. It's nothing, guys. This is just rearranging the term. I just put this term next to this. Okay, this term is here, just next to this, and then I move this term to the back. That's it. Okay. Okay. So the next one, I'll copy and paste this term. So I'll just put this in the same line to make it easier to read. Okay. So guys, I will divide the whole equation by x squared plus y squared. So I have y dx plus x dy plus x dy plus, minus y dx divided by x squared plus y squared equals 0. Okay, I basically divide the whole equation by x squared plus y squared. So this disappeared, and we have x squared plus y squared here, which is what we have here. Okay, and as you can see, guys, this is pretty simple. Y dx plus x dy. So we know that this guy is dxy. Okay, right? The tricky part is this guy, which is a little harder to see. First, guys, do you remember this formula? D by d theta of arc tan theta. What is it? Is 1 divided by 1 plus theta squared, right? So if I want to find the guys, you remember this formula, right? df is df xy is df by dx plus df by dy. You remember that formula, right? It's a total derivative. Okay, it's a differential form in two variables. Okay, so if I want to look at d of arc tan y divided by x, what is it? That would be d by dx of arc tan y divided by x dx plus d by dy of arc tan y divided by x dy. Right? And guys, d by dx of arc tan y over x. Okay, I'll look at this one first. Okay, let's look some other colors. Let's look at this one first. We need to take this variable as u, right? And then we apply the chain rule. Remember? Okay, so we have 1 over 1 plus y divided by x squared. It's the same as here. To look at this as theta, okay, it's 1 divided by 1 plus theta squared, which is this. Okay, because I look at y divided by x at theta. And then we need to, by the chain rule, we need to differentiate y over x by x, and then we have dx. Okay, this is the same as that. Make sense? First, we look at this as theta, and then we have 1 over 1 plus theta squared, which is this theta. And then we need to differentiate theta by x, right? We use the chain rule. And similarly, for the next one is 1 divided by 1 plus y divided by x squared, and then we need to differentiate by y of y over x dy. Okay, is that good? And then I pull the, I'll pull this out. So what I have is 1 divided by 1 plus y squared divided by x squared, and then times d by d. Okay, what is d by dx of y over x? It will be d by dx of y x to the power of minus 1, right? That's y over x. And if you differentiate it, you get minus y x to the power of minus 2. Okay, which is minus y divided by x squared. Make sense? So here you have minus y divided by x squared dx plus if you differentiate y divided by x by y, you get 1 over x, right? And that is 1 over x dy. Okay. Then I multiply x and x here to make it x squared, right? Because I have x squared here, I want x squared here as well. And then I multiply this by x x squared and x squared as well. So what I have is it equals 1 divided by x squared plus y squared divided by x squared. Okay, times minus y dx plus x dy dy divided by x squared. Okay, and that is the same as, what is it, x squared divided by x squared plus y squared times minus y dx plus x dy divided by x squared, and this got cancelled out. And guys, this is actually this yellow thing. It's actually this guy, if you compare, right? X squared, y squared, x dy minus y dx. See? So we have that this guy is actually d of arc tan of y over x. So we have that the equation becomes dxy plus d of arc tan y over x equals 0, which means that it's dxy plus arc tan of y over x equals 0, which means that is xy plus arc tan y over x equals c, and that is the solution. How was it? It's quite hard, isn't it? Right? But don't worry, guys. Using the observation method, it's not our focus. Okay. So most of the questions you can solve it by the integrating factor. But I just show this example to you because just in case that you come across some questions that you can't really find mu in terms of x or in terms of y. Okay, right? Because for this one, as you can see, this one is not a function of x, so we can't use this, right? And this one is not a function of y, so we can't use this either. So we need to use the observation method. Okay, and that's the answer. Okay, the next and the last question, I'll let you to do it as an exercise again. Let me look at the solution. Just 1 second. The solution for this one is, again, this is not you can't find mu, because mu is not a function of y and not a function of x, so you need to use the observation method. Okay, and this is to let you practice that observation method, but it's a lot easier than the previous one. Okay, so the answer is x over y minus y over x minus 1 divided by xy equals c. And that's the answer. That's the solution. Okay? Okay. So you can try solving this problem yourself and see whether or not you can solve it. Okay? And guys, that's it for the first that is for the integrating factor section. Okay, I know I think this is the longest video that I have been shooting, but I want you guys to see lots of examples. I could have just show you guys the theorem and then give you 2 examples and that's it. I could have done that as well, but I want you guys to look at different examples, look at different cases, so that you guys are familiar with the approach. Okay, so let me sum it up a bit. So I'll just take you to the take-home message. Okay, first, when we have the equation, okay, and it's not exact, so we look here whether or not this is a function of x. If it's a function of x, we get the mu, which is this one. Okay, if mu is absolute of y, we can use mu as y. We don't need to care about minus y, because to multiply the whole equation by y or by minus y is the same thing. Okay, and if this is not a function of x, we look here whether or not it's a function of y. If it is, this is the mu. Okay, this is mu. Mu is e to the minus integrate g dy, and then when we get the mu, we just multiply this whole equation by mu, and that equation becomes exact equation. And then we have the f by the x and the f by the y, right? And then you can choose to begin with either one of them, and then you integrate, differentiate, and compare, and you receive the solution. Okay, so that's it for this video. In the next video, we're gonna look at another form of ODE called a Bernoulli equation. Okay, and it's a special case of what we did today. Okay, so we're gonna need to use the integrating factor as well. So we still need the integrating factor. Okay, so before going to the next video, try to understand this video first. Okay, if you understand this video, the next video is going to be fairly easy. But if you don't understand this video, the next video you're not gonna understand it. Okay, so try to go step by step. It's mathematics, guy. Okay, it's mathematics, it's not English. Okay, so you need to go step by step. Okay, from bottom to the top. Okay, so if you get stuck anywhere between the bottom and the top, just let me know. Okay, we can talk about that. Okay, so that's it for this video. So see you in the next video. Okay, bye bye.